Alright guys, and so today we're going to take notes that are a little more detailed than the notes we took earlier today. And we're going to create more specific types of bonds and how we can identify them. So we're going to be taking notes in this bottom left-hand corner. So as we zoom in, we're going to talk about 3 different types of bonds. We're going to talk about nonpolar covalent, we're going to talk about polar covalent, and we're going to talk about ionic. And so first, let's define what these mean. So our first is nonpolar covalent. In nonpolar covalent, our electrons are shared equally. So what that looks like when electrons are shared equally is you have one element, a second element, and we actually spend equal amounts of time around both elements. So the electrons are shared equally. So our second type of bond is a polar covalent bond, and this is when electrons are not shared equally. And what that looks like is we have 2 elements, and it spends a little bit of time around one, and a majority of its time around another. So instead of being even, it's shifted towards one side or the other. Our last type of bond is ionic. In an ionic bond, electrons are not shared at all. And what that looks like is we have our 2 elements that are completely separate, and one element takes an electron from the other. So nothing is shared. They're just taking them from one another. Now we're going to figure out how to determine what kind of bond we have based on the elements within the compound. And we're going to do this by using the difference between their electronegativities. So this chart right here, it's attached to the worksheet you're about to do. This is all of the elements' electronegativities. So difference means subtraction. So we're going to subtract the different electronegativities. So if the difference between our electronegativities are between 0.0 and 0.5, we have a nonpolar covalent bond. If our differences are between 0.6 and 1.9, we have a polar covalent bond. And any difference that's greater than 2.0, we have an ionic bond. So we're going to follow 2 steps in order to figure out these problems, and they're written in purple. First, we're going to find the electronegativities using this lovely chart once again, and then you're going to subtract them and take the absolute value. And that's because if you look up here, there's no negative numbers. And so all we care about is the difference between the 2 numbers you're working with. Once you've got your difference and your absolute value, you're going to figure out which range it falls in. And you're going to tell me whether it's nonpolar covalent, polar covalent, or ionic based on the number you get. So let's do a sample problem. Take a look at number 1. We have nitrogen and chlorine. So we're going to find nitrogen on our map. That's 3.0. We're going to find chlorine on ours. That's 3.0. We're going to subtract to get 0. We're then going to compare it to the chart we just finished, and we will find out that we have an nonpolar covalent bond. And that is our answer. All you're going to do is do that for 2 through 10.